The Pythagoras theorem is a cornerstone of a lot of what we do in geometry when we're doing surface areas and volume. So the Pythagoras theorem is a relationship between the three square areas from the side lengths of the right triangle. So we cannot add the side lengths together to get the third side length, but we can add the two smaller areas and it combines to the third area. And we could then go ahead and find the side length by taking the square and square rooting to find side length. So applying Pythagoras theorem here, we want to first of all find the area of the squares. So in this case here, 12 squared is going to give us 144. 5 squared is going to give us 25 squares. And the sum of those two areas adds up to the area from the hypotenuse. So when we add these two areas together, we get 169. Okay, so the circled bits represent the areas. To go from side length to area, we square. We want to find x. So finding x, we're going to take the area and square root it. And we get the length of x is equal to 13. So when we look at the lengths here, 12, 5, and this is going to be a little bit longer than 12. Again, make note that this is definitely not 12 plus 5 equals this length here. Okay, that would be way too long. So looking at this one here, we have the square area is going to be 25. We're trying to find one of the smaller side lengths. So to find that, we're not going to add this square here. So this square is going to be 64. We don't add these two together because that would give us an area that's much bigger than the square that we're going to get from here. So we have to remember that if we're finding one of the shorter side lengths, we have to subtract. So when we subtract this, we're going to end up with 39 squares. And go from the squares to the side length. Okay, we're going to square root it. So x is equal to exactly square root 39, which is approximately, if we work out the decimal value for this, okay, getting my calculator out, I need to work out the decimal values. Okay, so I'm going to do square root 39, and I get approximately 6.244, so I'm going to round that to 24. So here, if we want to calculate the area and perimeter, we are going to need to solve for that unknown side length first. So I'm going to use Pythagoras. It is a shorter side length, so the way I'm going to set it up is I'm going to take the area, square area from the longest side. I'm going to take away the square area from one of the shorter sides, and that's going to equal the square area from the side that I want. So 29 squared minus 21 squared. Okay, so let's write this out. 29 squared is 841. 21 squared is going to be 441. That's going to be equal to x squared. We subtract those. The left side of that equation is 400 equals x squared. If I want to find the side length, I need to square root both sides. Okay, so I get plus minus. So x is equal to plus minus 20, but we don't need the negative, so we're just going to say that x is equal to a side length of 20. And again, remember that what we're working with here are the areas, and we still need to convert this to side length by square rooting.